LangGraph's message handling mechanism employs a straightforward list-based approach for managing conversational state, utilizing distinct message classes to differentiate between human and AI-generated content. This design allows for clear separation of concerns while maintaining a simple, linear structure for message storage and retrieval. We're about to examine how this system initializes message lists using specific message types and demonstrates their combination through a dedicated merging function. The code will show the creation of two separate message lists, each containing a single message instance, followed by their concatenation into a unified sequence.
From LangChain core, messages import AI message, human message. MSGS1 equals human message content equals hello. ID equals 1. MSGS2 equals AI message content equals hi there. ID. Add message mx1, MSGS2. Hash human message content equals hello. ID equals 1. AI message content equals hi there. ID equals 2.
This example demonstrates LangChain's message handling system, specifically the human message and AI message classes, along with the add messages utility function. The code shows how these message types represent different roles in a conversation, with human message for user input and AI message for system responses, each carrying content and a unique ID. The add messages function merges two message lists while preserving order, creating a unified conversation history. This pattern is crucial for maintaining context in multi-turn interactions, where message sequence and identity matter. The ID-based approach allows for potential message updates, though the example shows simple concatenation. This design enables clean separation of concerns between message types while providing tools to manage conversation state. The explicit role typing helps downstream processing distinguish between user and system messages, which is particularly valuable in complex workflows where message provenance affects behavior. The simple merging strategy works well for linear conversations, but may need extension for more complex scenarios like message editing or branching dialogues. Let's break it down.
From LangChain core, messages import AI message, human message.
Imports two message classes from LangChain's core messages module: AI message for messages generated by AI systems and human message for messages originating from human users. These classes provide structured representations for different types of conversation participants in a chat system.
MSGS1 equals human message content equals hello. ID equals 1.
Creates a list named MSGS1 containing a single human message object with the content hello and an ID of 1. This establishes a message collection where each message has both content and a unique identifier for potential merging operations.
MSGS2 equals AI message content equals hi there. ID.
Creates a list named MSGS2 containing a single AI message object with the content hi there and an ID of 2. This represents a message from an AI system stored in a list structure for potential use in message merging operations.
Add message mx1, MSGS2.
Calls the add messages function to merge two message lists, MSGS1 and MSGS2, updating any existing messages by their ID while preserving the order of the original lists. The function handles the combination logic internally, producing a single unified message list as output. LangGraph's message handling employs a clean separation of concerns through distinct message classes for human and AI content, with human message and AI message providing explicit role typing. The linear list-based storage maintains conversation order while the ID system enables potential message updates. The add messages function demonstrates this by merging two message lists while preserving sequence, creating a unified conversation history. This design balances simplicity for linear conversations with extensibility for more complex scenarios, though it may require adaptation for advanced use cases like message editing or branching dialogues. The explicit role distinction proves particularly valuable in complex workflows where message provenance affects downstream processing behavior.
Messages merge by ID, yet their ghosts persist, each addition a phantom that clings to its past.